Hello, this is the luckiest maths teacher in the world. Thank you so much for watching as we're having a review of equations, which you've already done. So what is an equation? So it's something with an equal sign. And we're looking at solving for a pronumeral. So we're looking at things like this. A plus 2 equals 7. Now this is a very, very simple equation to solve. You can probably solve it without having to do any techniques. You can probably just look at the equation and know what the solution is. So what I mean by solution, and when we solve an equation, we want to find a number that I can substitute for A that makes this a true statement. So there's one and only one solution in the kind of equations that we are doing in this course. So you probably know straight away that the solution to this is A equals 5, right? And that's because if I change A to 5 in this equation, so I rub out A and I write a 5 instead, I get a true statement. 5 plus 2 does equal 7. That's true. If I substituted any other number, let's say I substituted A equals 4, then what I would get, if I rub that out, I get 4 plus 2 equals 7. That's not a true statement. So A equals 4 is not a solution. The solution is very clearly 5, and that is the only number that I could have exchanged for A to make this a true statement. So A equals 5 is the one and only one solution. So now that you know what a solution is, how do we actually solve equations? So we're going to do more complicated equations than just A plus 2 equals 7, So let's have a look at a few examples. So let's say we're going to do the equation 2x plus 1 equals 45. So the goal here is the same. I want to find a number that I can substitute for the pronumeral, the letter x, that makes this a true statement. And there is only going to be one such number. So there are two ways that you can do it. Both of them, though, have the same method behind them. They have the same idea behind them. And that is we have to undo everything that has been done to x in order to get x by itself. So the first method we can use is flowcharts. So what we do is we tell the story of what's happened to x and then undo it. So here, 2x plus 1 means that I took some number x, I don't know what it is yet, and I times it by 2. And that's how I managed to get 2x. Then I added 1. Now it's important I get the order of operations right here. I times by 2 first because of BODMAS. And then I added 1 to get 2x plus 1. So how I solve the equation is I start with the solution and I work backwards. So instead of adding 1, I need to subtract 1. So 45 minus 1 is 44. Then, to go back to the start, instead of timesing by 2, I do the opposite. I divide by 2. So 44 divided by 2 gives me 22. And therefore, my solution is x equals 22. So each of these things above each other, they are equal. So 2x equals 44, 2x plus 1 equals 45, x equals 22. That is the solution. So I've just undone everything that has been done to x. The other method is the balance method. That's the one more commonly used, and you don't have to draw flowcharts for it. But it actually doesn't matter. Whichever method you use, I'm happy as long as you can solve it. So 2x plus 1 equals 45. We're doing the same thing. We're undoing what's been done to x. We just have to make sure that when we're solving an equation, we do things in the opposite order to BODMAS. So first up, I minus 1 from both sides. So plus 1 and minus 1 cancel each other out. That's why I did it. So I'm left with 2x equals 45 minus 1, which is 44. Exactly what I have here. And then if I want to undo, so 2x means times by 2. If I want to undo timesing by 2, I divide by 2. So 2x divided by 2 is just x. 44 divided by 2 is 22. I got the same answer. The solution is x equals 22 because if I take this equation here and I change x to 22, I get a true statement. 2 times 22 plus 1 does equal 45, all right? Let's just look at one more example. So let's look at this equation here. Now, the reason I chose to do this is it involves negative numbers and it doesn't have a whole number answer. And people, for some reason, they always think if they're solving equations, okay, we've got to have a whole number answer, it's got to be a positive number. That's not true. Answer can be a fraction, can be a decimal, negative number, whatever. This might look different because it has a decimal and a negative answer, but we do it exactly the same way. So the first method I taught was the flowchart method, so we write what's happened to x. So I took x, I times by 7, that's how I got the 7x. Of course, I need to do the times before the subtraction here because of BODMAS. So then after timesing by 7, I took away 5, and that's how I got 7x minus 5. So to solve this equation, I start with the answer, minus 36.5. These two are equal. Instead of subtracting 5, I add 5. So then I get minus 31.5. So then, instead of timesing by 7, I divide by 7. So if you go minus 31.5 divided by positive 7, the answer will be negative because it's a negative divided by a positive, and it will be negative 4.5 or 4.5. Nothing wrong with having a fractional answer. Nothing at all. So the solution here is x equals minus 4.5 or minus 4.5. If it makes more sense, you can use the balance method. Same idea. I want to undo everything that's been done to x, and when I'm undoing or solving, it needs to be in the opposite order to BODMAS. So I'll undo subtracting 5 by adding 5 to both sides. Of course, negative 5, positive 5 cancel out. So I get 7x equals a negative 36.5 plus 5. And then I have 7 times x. I undo timesing by 7 by dividing by 7. And then I'm left with the same answer. You can use your calculator for this. X equals minus 4.5 or minus 4.5. How easy is that? Use this process on all the equations that we're doing in this lesson. A big problem people have in maths is they freak out. They see a question that's slightly different and they're like, what do I do? But you can use this method on any equation we're doing today. Hope you've enjoyed this video. This has been the luckiest maths teacher in the world. Have a great day.